Hello, welcome back to another video. And today I'm going to be going over some basic U-substitution for indefinite integrals. So let's get started. So when I first look at a U-substitution problem, I always want to look at, are there special parts that I can substitute for? Because usually that's what you're going to have to replace, the special parts. So what I mean for that is, you see the dotted lines here, these dotted lines and these dotted lines. I mean, whatever phrase is in there. So it's, let's say up here it said x squared plus 1, your u would be x squared plus 1, and then you do the whole dance that you do with it. Alternatively, it would be in a radical sign, or it would be in the denominator, or it would be in the radical sign and a denominator, etc. So yeah, that's what I mean by special parts. And also, you should look for easily substituted parts. So what I mean by that is, it's in a good example that I'm about to do. But for example, if you see a sign that could easily be made the derivative, and there's also a cosine that can be substituted out, you would know that you'd want to make your u that sign, because it will cancel out different terms in the problem, and you just have a lot more time finding a much easier time finding the integral, basically. Okay, so what do you do for u substitution? So basically, you make u equal to whatever you're substituting. Then you find the derivative of that. So this is the derivative. And then basically you just multiply the dx to the other side. Simple as that. And then you just substitute that in. And so let's hop right into a problem. This is actually an A and B problem. So find the following integrals using an appropriate substitution. Okay, so let's start with A. We have the integral of 3 times 6x minus 1 times e to the 3x squared minus x dx. Okay, so there are a couple special parts. I would say that this is a special part and this is a special part. And there are two ways I'm going to choose. Actually, really only one good way. If I take the derivative of this up here, I'll get 6x minus 1. And I can see that just by looking at it. Alternatively, you can just prioritize things that are above the e, because in my mind, they're more special. I don't know. That might be a stupid way to think about it, but that's how I do it and it works. So let's just do it. So if we make the u equal to 3x squared minus x, the du over dx is going to be 6x minus 1, and therefore du equals 6x minus 1 dx. So now if we look back at our problem, we can see it's actually a very easy solve from here. So if we now substitute, we're going to have the integral of 3e to the u. And then this that I just circled, the 6x minus 1 dx, gets them completely substituted in for du. And that's what I mean by look for something that can easily be switched out, right? We can see that the 3x squared minus x, if we find the derivative of that, we can easily switch out the 6x minus 1 dx, because we could switch that out for du. So now we have this. Now, as you can probably guess, it's a super simple solve. We're going to have, from here, we're going to have 3e to the u plus c. And then we have 3 equals 3e to the 3x squared minus x plus c. And that is our answer. So now, moving on to B, I'm just going to make this a little bit smaller. Moving on to B, we have cotangent, the integral of cotangent x dx. So what is cotangent really? Cotangent is cosine x over sine x dx. So remember what I said before, look for either a special part. So I'd say the denominator is more special than the numerator. But more importantly, you should look for what can you easily substitute out. If we take out sine x and find the derivative, what's the derivative of sine x? Cosine x. So then we could just simply substitute out for cosine x, and we'll have such an easy time. So if we make the u equal to sine x, we'll have the du equal to cosine x dx. So now substituting in, we'll simply have the integral of 1 over u du. And now look how simple this is. What's the integral of 1 over u? Ln u plus c. That's what that equals. Now, one more step to go. Ln of sine x plus c. Done. So let's go on to one more problem. I guess pause the video and see if you can do this by yourself, but I'm going to dive right into it so I don't take up any more of your time. So find the integral of x times the square root of x plus 1 dx. Okay, so I think it's pretty obvious which one we're going to want to substitute in for the x plus 1. So if we say u equals x plus 1, we have du equals 1 dx. So du equals dx, basically, which isn't super helpful, but it still lets us solve the integral by substituting in du. So we'll have the integral of x times u to the 1/2 power du. And so basically what we did was we plugged in u for this, and instead of putting the u in a radical, we simply just made it to the 1/2 power, which is the same thing as a radical, as I'm sure you know. Okay, so now what can we do from here? Maybe you got a little stuck, or maybe you're not really sure what to do. But basically, what you want to do from here is you want to just make what is u? U is x plus 1. So what is x in terms of u? It's u minus 1. So we have u minus 1 times u to the 1/2 du. And from here we can multiply, and we'll have u times u to the 1/2. This is basically u to the 2 over 2 times u to the 1 over 2, which gives us u to the 3 over 2 because exponents add. So we'll have u to the 3 over 2 minus u to the 1 over 2 du. All right, so now time to find the integral. So that equals, okay, so we have to add 1 to the exponent when we're finding the integral. So plus 2 over 2 is 5 over 2. So u 5 over 2 divided by the exponent. So 5 over 2 minus, same thing here, so minus u 3 over 2 over 3 over 2 plus c. Now last step, we have, let's just flip the denominators, and u to the 5 over 2, just sub in for u. We said u was equal to x plus 1. So we have 2x plus 1, 5 over 2, minus 2 over 3, x plus 1, 3 over 2 plus c. And that is your final answer. Thank you for watching, and I hope this helped a lot. Adios.